Hello everybody, welcome back to Mr. J's Math Show. Today we're looking at lesson 3.3, which is Slope-Intercept Form, or OIT. So graphing linear functions and showing intercepts. So vocab is parent function, linear equation, y-intercept, slope-intercept form, or OIT. Okay. A family of functions. So a family of functions is a group of functions with common characteristics. So every function belongs to a certain family. Okay. A parent function, so all families have parents, hopefully. A parent function is the simplest form of that function. So with a linear function, like y equals mx plus b, the parent function is just y equals x. Okay, so that's the simplest form of that function, like this. Or we can say f of x equals x. The graphs of three linear functions are shown at the right. So the parent function is this red one right here. This goes up through that, that's y equals x. Then we have y equals 2x, so the parent function has changed a little bit. That is not a parent function. And then we have negative 1 half x plus 1, so that's shifted and changed the parent function as well. But you can see that they all are lines, so they all belong to the same family of functions. A linear equation is an equation that models a linear function. In a linear equation, the variables cannot be raised to a power other than 1. So y equals 2x is a linear equation because x is to the first power. But y equals x squared or y equals 2 to the x are not. So your variable can only have x, your equation can only have x to the first in order for it to be linear. The graph of a linear equation contains all the ordered pairs that are solutions of that equation. So if you look here, graphs of linear functions may cross the y-axis at any point. A y-intercept of a graph is the y-coordinate of a point where the graph crosses the y-axis. So the parent function has a y-intercept of 0, because it's y equals x plus 0. If we look at the blue one down here, like this, that one has a y-intercept of negative 3, because it goes down 1, 2, 3. You can use the slope and the y-intercept of a line to write and graph the equation. So slope-intercept form looks like y equals mx plus b, where m is the slope and b is the y-intercept. So you only have to fill in two things here. Y and x, those are going to be your variables, so we don't change those unless we're changing them to help us find the slope or the y-intercept. But when you write your equation, you're always going to leave y and x because those are your variables. So you just change m for slope and b for y-intercept. Okay, next. Okay, what are the slope and the y-intercept of the graph? So if you remember the equation, y equals mx plus b. We have our y and we have our x. So m is going to be whatever is attached to the x. So in this case, m is 5. And b is going to be the minus 2 here. So the minus has to stay with it. So it's negative 2. So your slope is 5. Y-intercept is going to be negative 2. So using that, we could actually graph it, but we're not going to do that right now. Okay, so look at this one. Try to answer these two questions, and we will talk about it in a second. Pause this in 3, 2, 1, pause. Welcome back. Okay, so A, for this one, your slope is going to be the 1/2 right there, and your y-intercept is going to be the 2/3 right there. Next question says, if we move it down 3 units, how does that change the answer? Well, your slope doesn't change because it's still going to be the same angle and whatnot. We're just going to move it down like that. But your y-intercept would go down by 3, so we would do 2/3 minus 3, which I did right here, and came out to be negative 7/3. Fascinating stuff. All right. Next, we're going to write the equation, so doing it backwards, writing the equation given the slope and the y-intercept. So if you remember, slope is going to be m. So our m is negative 4/5. Y-intercept is b, so that's 7. So I just plug it into my equation, y equals mx plus b. Remember, y and x stay the same. So we just plug in m, which is negative 4/5, and b, which is 7. And that would be your equation. So this guy goes over here, shabam, there we go, and he goes there. Okay, you go ahead and try this one, write the equation, and then I will do it as well, and we'll compare our answers. Pause this in 3, 2, 1, pause. All right, so again, your slope goes here with the x, so 3/2 minus 1 is the y-intercept, so 3/2 x minus 1. Y equals 3/2 x minus 1 should be your solution. All right, which equation represents the line shown? Okay, so this one you have to actually look at the graph. And the first thing you want to do is locate the y-intercept, which is going to be where it crosses the y-axis here. And you can see it's crossing right there at -2. So our y-intercept is -2. Then the next thing you want to do, because you already know where the y-intercept is, you want to find another point, a nice point. So maybe like this one right here, or this one right here. And you want to find the slope between those two. So this one you got to go up 2 over 1. So rise 2, run 1. That gives you your slope here. So our slope, rise over run, is going to be 2 over 1, which is just 2. So our equation should be y equals m, which is 2, x plus b, which is minus 2. So 2x minus 2, which would be this one right there. Hooray. Okay. We have a lot more to do here. Okay, wait, I skipped one. Sorry. Okay. Go ahead and try this one, and then I will do it as well. Okay, pause this in 3, 2, 1, pause. All right, so the first question says, what do you expect the slope of the line to be from looking at the graph? So if you look at the graph here, notice that it cuts through every square. So your slope should be -1 because it's going down. Remember, you can just look at your graph to figure out if it's a positive or negative slope. So our equation would be y equals -1x, or just y equals -x. That's your slope, plus 2, because 2 would be the y-intercept here. It goes up 1, 2. Okay, does the equation of the line depend on the points used to find the slope? No, because your slope should be the same. It's a constant rate of change, so no matter what 2 points you use, your slope should always come out to be the same. Okay, next. Okay. All right, so now it's giving us 2 points, and it wants us to write the equation in slope-intercept form. So when you're given 2 points like this, it takes a little bit of extra work, but the first thing you need to do, step 1, is to find the slope. And remember, your slope formula is going to be y2 minus y1 over x2 minus x1. Okay, so you're subtracting the y's on top and the x's on bottom. So I'm going to say this is x1, y1, x2, y2. So the first thing I do is -8 minus 1 on top over 5 minus 2 on the bottom. So that gives me -9 over 3, which divides out to be -3. So our slope is -3. Now this is the tricky part, because we found the slope, but we can't find the y-intercept by just looking at these 2 points. So what we can do is we can remember our equation, y equals mx plus b. Okay, and I know the slope now is -3. So I'm going to plug -3 in for the slope for m. And then to find b, I can pick one of these points here. So 2, 1, or 5, -8. I'm going to pick this one because these look like easier numbers. And I'm just going to substitute those in for x and y. So this is our x, that's our y. So I'm going to plug in 1 for y, -3, and then for x I'm going to plug in 2. And then I still don't know what b is. And now I can solve for b by solving this equation. So I get 1 equals -3 times 2 is -6 plus b. Solve this equation, I have to add 6 to both sides. So then I get 7 equals, those cancel, b. So b equals 7. So now that I know b, and I know m, which was up here, now I can write the actual equation, which is y equals m, which was -3x, plus b, which was 7. So when I write the final equation, you are not leaving in the 1 and the 2 here, because we're going to change them back to y's and x's. Okay, so the only thing you change in the final equation is the m and the b, like that. Okay, so we substituted them in to find b, but when you replace them and write the actual equation, you just leave y and x the same. Okay, so go ahead and try that with this one, and then I'll do it up here as well. And it doesn't matter what point you pick when you're plugging him back in. So don't worry about that. Okay, pause this in 3, 2, 1, pause. Okie dokie. So I found my slope, which was positive 1/2. And then I plugged it back in, and I used this point to plug in. You could have used the other one as well. It doesn't matter. You should get the same thing. But I plugged in -3 for y, plugged in 1 for x, solved for b, and I got b equals -3.5 or -7/2. And then I just plugged in m and b. So I got y equals 1/2 x minus 7/2. Right. Okay, next thing. Okay, now we're graphing. Ooh, getting to the fun stuff. Okay, so looking at this, we need to graph it. So first thing you want to do is, well, make a graph probably. Bada bing, bada boom. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Try to make it proportional if you can. So we want to look at and find the slope. So what's touching the x? Well, that would be the 2 there. So 2 is going to be your slope. And then the -1 is going to be your y-intercept, or b. So when you're graphing, you want to start at the y-intercept, which in this case is -1. So I'm going to start down here at -1 on the y. And then my slope is 2. So I'm going to make that a fraction by putting it over 1. And I'm going to rise 2. And run 1. So from the -1 here, from this point, I go up 2 and over 1. And that's my next point. And then I could do it again if I wanted. 1, 2, over 1. And so on. I could even go down 2 and back 1. And it should all fall on the same line. Okay, and then you just grab your line and sketch it out like that. Okay, make sure that your line matches the slope. Okay, our slope is positive, so our line should be going up, which it is. Okay, I'm going to have you graph both of these, and I'll do it as well. So go ahead, pause this in 3, 2, 1, pause. All right. Okay, so the first one, we started up at 4 here. That's your y-intercept. And then I went down 3, 1, 2, 3, and over 1, because it's negative, so I went down. And notice it's negative slope, so my line should be going down, which it is. This one I started down here at -8. It was a very ski-wampus graph, so it doesn't look very good. My apologies. But I started at -8, because that was the y-intercept. And then I went up 4 and over 1. So rise 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. It should look like that. And it's positive, so it's going up. Okay, couple more. Okay, so we have this real physics problem here. So slope-intercept form is useful for modeling real-life situations where you're given a starting value, the y-intercept, and a rate of change, or the slope. So water pressure can be measured in atmospheres, ATM. Using the information in the diagram, write an equation that models the pressure y, so y is the pressure, at depth x meters. What graph models the pressure? Okay, so if you notice here, it says at 0 meters, the pressure is 1 ATM, or 1 atmosphere. And this one says the pressure increases by 0.01 atmospheres per meter. So this is going to be your rate of change, or your slope, and then this is where it starts at. So when x is 0, your y is 1. So that's going to be your y-intercept, or b. This is going to be your slope. So your equation would be y equals 0.1x plus 1, not 0, because your y is 1. Okay, and then the graph, if you wanted to graph it, would look like this. So you would start at 1, which is here, and then you'd be going up 0.1, or you can also write that as 1/10. So you could say y equals 1/10 x plus 1. So then you'd rise 1 and run 10, which I don't have enough points for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I have 10. Okay, so you rise 1 and then run 10, which would be over here. Okay, so this is not very steep graph. This would be your y and your x, or your meters and your atmospheres, like that. Okay, so that's what that would look like. Okay, I'm going to let you try this one. It says a plumber charges $65 fee for a repair plus $35 an hour. Write an equation to model the cost y of a repair that takes X hours, and then make the graph. Okay, go ahead and pause this and try it in 3, 2, 1, pause. Okay, so 65 would be the initial fee. So that's going to be your y-intercept, and then 35 per hour. So usually whenever it says per, that's going to be your slope. And since we're talking about x as in hours, that's definitely your slope. So 35x plus 65. So we're going to start by graphing at 65 on the y-axis, which is this point. And then you're going to rise 35 and run 1. Notice I went by 10s here, and 1's over here. So if I go up 35, that's going to be up to 90 over 1. So then my graph would look like this. And yeah, and I don't need to go back into the negative because you can't work for negative hours. So that would be it. All right, that is all I have for 3.3. So thanks for watching. Make sure you like and subscribe. Leave a comment if you want. Make sure it's nice. And I'll see you guys later. Okay, thanks, bye.